Assalamualaikum, Madam. My name is Muhammad NURFADZLI bin Ahmad, and my matrix card number is B0819100211, and my group member is NABIL ILMAN, and I'm ASHRAFF. So I would like to show the construction of power factor correction circuit for lab 3. So first of all, we click to the draw, then network. So click on bus. Here we insert the nominal voltage, which is 16 kilovolt. So the orientation is up because we want vertical position, and bus information system select bus. So now we insert the second bus. The value of nominal voltage are same, and the orientation is right. So okay. Okay, so now we insert the generator. And for generator, megawatt is 100 megawatt and 75 mega VAR. 75. And display information left. Okay. Next, insert the transmission line from bus 1 to bus 2. So for transmission line, X we put 0, limit A 200, limit B 100, limit C 100. So now we insert the switch shunt. Nominal MVAR put 0, and this discrete put 10 and 20. Okay. So for load here we put 100 megawatt and 75. Value here we change it to 1. Same with this. 1. And the value of bus bus voltage kilovolt. Okay, so same with the second bus. Kilovolt. Okay, that's all. Okay, now for run mode, tools. Okay, so here we can see the green arrow is real power. So if we want to see the reactive power, click here. Yeah, so the blue arrow is reactive power.
Assalamualaikum, my name is NABIL. Today I will show the simulation for lab 3 for power factor correction, and this is the circuit that my friend have construct. And when we run the simulation, we can see there is 2 arrow from bus 1 to bus 2. There is 2 arrow which is in color green and color blue. For the color blue, it represents the reactive power, and the green color it represents for the real power. As you can see, we have connect the switch shunt at the bus 2, and we can control the megavar for the switch shunt. when the switch is in 0.0 megawatt, we can see the reactive power and the real power is equal in value from bus 1 to bus 2. And when I increase the value of the megawatt to 20, we can start to see the value of reactive power is smaller or decrease than the real power from bus 1 to bus 2. And until if I increase to the 60.0 megawatt, you can see the value of reactive power is quite small, quite small than the real power, and also we can see the reactive power flows in the switch shunt. That's all for my simulation. Thank you.
Okay, so for the next part, need to calculate the source and load apparent power, reactive power, and power factor before and after increasing the reactive compensation. The first one is before increasing the reactive compensation. So the value for power is 100 megawatt, and the value for reactive power 75 megawatt. So to calculate the apparent power, need to use formula power plus imaginary reactive power. So the value for power is 100 mega, and the value for imaginary apparent reactive power is 75 mega. So the answer will be 125 mega, and the degree will be 36.87. So next, for the power factor is cos 36.87. So the value will be 0.8. So next, we increase the reactive composition to 20 megawatt. So the value for power still same, 100 megawatt, and the value for reactive power is 55 megawatt. So to calculate the value, to calculate the apparent power, need to use the formula power plus imaginary reactive power. So for power, 100 mega, and for imaginary reactive power, 55 mega. And so the value we get 114.127, and for the degree is 28.81. So to calculate the power factor, need to use formula cos 28.81, and the answer will be 0.88. And for the last one, 40 megawatt. The value for power still same, 100 megawatt, and the value for reactive power is 35 megawatt. So to calculate the apparent power, P plus imaginary reactive power. So the value for P is 100 mega, and for imaginary reactive power is 35 mega. So the answer will get 105.95, and the degree will get 19.29. And to calculate the power factor, cos 19.29, and the answer will be 0.94. That's all. Thank you, madam.